Hello students. In previous classes we were discussing about electricity and more is end of chapter 8, and in the next class I'll be discussing problems. So in today's class we will be discussing about solve problems given to you in your textbook. Okay, solve problems. So our topic for today is solve problems. I'll try to complete all the solve problems in today's class and see next class let us solve the exercise problems. Okay, let us not waste more time. I'll directly go into the solve problems. So your first question is example problem. That is example 2.1. Okay, example 2.1. I wish you have gone through the notes of previous class. In that class, in that notes, I have given you the formula list for all the given physical quantities. It will be better if you keep that notes aside so that it is helpful for you to go through the formulas. Okay, now formulate. Now I am going to solve the problem regarding the electric power and electric energy. That in that notes, I have given you the formula for all the physical quantities. Please check out the question formula. Now let me just directly start with the question. Okay. Yeah. I'm going to write the question. A conductor. Okay. A conductor. I hope you have received your textbooks already, so that it will be helpful for you to follow. By the filament of an electric bulb. Of an electric bulb for 10 minutes. Bulb for 10 minutes. Okay. Now find the amount of electric charge flowing that flows through the circuit. Okay, so this is the question asked to you. This is the question asked to you in the example 1. A current of 5.5 ampere is drawn from a filament bulb. That means the filament bulb, through the filament bulb, there is a current of 0.5 ampere flowing in the filament bulb for duration of 10 minutes. Find the amount of electric charge that goes through the circuit. This is what they are asking. So now let us first write down whatever is given. So given, what is given? Current. So given current flowing I is equal to writing any physical quantity. I'm sorry, I did a small mistake here. Very sorry. Yeah, whenever they get any physical quantity, you should first convert those physical quantities into their SI units. So now I have got ampere. SI unit of current is ampere, so this is 0.5 ampere. And the time taken T is given in 8 minutes. So minutes is not the SI unit of time. So I have to convert minute into seconds because seconds is the SI unit of time. So to convert 8 minutes into seconds, I'll be getting it as 8 into 60. Okay, 60 seconds. 8 6 are 48. So 48 into 480 seconds. Okay, so 8 minutes is equal to 480 seconds. Now I have to calculate the electric charge. Electric charge Q is the question mark. Charge flowing through a filament bulb when it is run for 8 minutes and the current flowing through it is 0.5 ampere. Okay, so this is the question. Okay, this is the answer. Oops, sorry. This is 10 minutes. I better it as this is 10 minutes. So this is 10 into 60, that is 600 seconds. So this will be 5 into 600. 5 into 60 is 300 coulomb. Okay? I'm sorry I just wrote this question wrong. It is 10 seconds. 10 minutes here. I rounded wrote it as 8. So 10 into 60 is 600. Then for 0.5 in the place of t I write 600. So 0.5 into 600 is 300 coulomb. Okay? So this is the answer for your example 2.1. Let me move on to the next question. So the next question is example. There is a question asked to you calculate the number of electrons constituting in one charge. This is not example problem, but there is a question asked to you to calculate the number of electrons constituting one coulomb of charge. Okay, so now you have to calculate, in this question you have to calculate the number of electrons that are required to make this 1 coulomb of charge. Okay, so the charge is 1 coulomb. In order to make a charge of 1 coulomb, how many electrons are required? This is what we have to calculate. So 1 coulomb, so Q is equal to N into E. This is the basic formula where Q is the charge, N is the number of electrons, and E is the charge on electron. We know E is equal to 1.6 into 10 power minus 19 coulomb. Okay, so charge of E is 1.6 into 10 power minus 19 coulomb. So in order to make this Q as equal to 1 coulomb, the question is to make this Q as 1 coulomb. So I'll substitute these two here. So 1 coulomb is equal to N into 1.6 into 10 power minus 19. Okay, so I have to calculate N. Therefore, I will just cross multiply 1.6 here. So 1 by 1.6 into 10 power minus 19 is equal to N. Here I need not write the unit, I will just write the quantity. So N is equal to 1 by 1.6 into 10 power minus 19. 1 divided by 1.6 is nothing but 10 divided by 16, which is not possible. So I write it as 0. I put a point and take 0 here. This is normal division. So 16 6 are 96. And there is a 4 remainder. 16 2s are 32. So there is a 8 remainder. 16 5s are 80. Okay, therefore 0.625 N is equal to 0.625 into 10 power 19. See, when 10 power minus 19 is in the denominator, I will have to take it to the numerator. So it becomes 10 power plus 19. So this is 0.625 into 10 power 19. That can be written as 6.25 into 10 power 18 numbers. So 6.25 into 10 power 18 electrons will make up a charge of 1 coulomb. This is how we have to solve this problem. The formula utilized here is Q is equal to N into E. Understood? So let's move on to the next question. Example 12.2. The question is, how much work is done in moving a charge of 2 coulomb across 2 points having a potential difference of 12 volts? So they are asking you to calculate work done. Okay, work done. You have to calculate work done. Okay, in moving a charge of 2 coulomb. In moving a charge of 2 coulomb across 2 points having a potential difference V, and we denote potential difference V as 12 volt. Okay, 12 volt. It is given potential difference V is 12 volts. So you have to calculate the amount of work done in moving this charge of 2 coulomb across 2 points having a potential difference of 12 volt. Okay, so now I have a formula. Work done is equal to Q by V. Okay, so I will substitute Q and V. Q is 2, V is 12. So this is 1 by 6. That is 1 by 6, which is equal to 1 by 6. 1 divided by 6. So 1 cannot be divided by 6. So I put a point and take 0 here. So 6 ones are 6. 4 is the remainder. Then I put a 0 here because 4 is not divisible by 6. So 6 are 36, and again 4 is the remainder. So again I take 0 and this is 6. So it goes on. So 0.166 is the value. And now what is the work done? Unit of work done is joule. So work done is equal to 0.166 joules. So this is the solution for this question. So they had asked you to calculate the work done and you have calculated the work done. This is how you solve the problem 12.2. Okay. So this is how we will solve the problem 12.2. And now let me move on. There is a question asked to you. How much energy is given to each coulomb of charge passing through a 6-volt battery? How much energy is given to each coulomb of charge passing through a 6-volt battery? Passing through 6-volt battery. Okay, so they're asking you to find out the energy that will be given to each coulomb, that is 1 coulomb of charge when it is passing through a 6-volt battery. Okay, so now we have to calculate energy. Okay, it is given charge Q is equal to 1 coulomb and potential difference V is equal to 6 volt. These are the data given to you. So now what you have to calculate? Energy. Okay, we know energy is equal to work done. I have explained you this concept in your class. While explaining you the concept of potential difference, while explaining the concept of potential, I will explain you and while explaining the concept of potential energy and explain you energy is equal to work done. Okay, so energy is equal to work done and we know work done is equal to Q by V. So Q is 1 and potential difference is V, so 1 by 6, that is nothing but 0.166 joules of energy. Okay, so this is how you have to solve this problem. Okay, so let me move on to the next problem. This question is asked to you in page number 96. This question was asked Okay, page 96, question 3. This question was asked to you in page 96 in question number 3. Okay. So the next problem is based on resistance. The next problem is based on resistance. Example 12.3. Example 12.3. Then they asked you how much current will an electric bulb draw from 220 volt source. There is two questions, A and B. Okay. So first question is how much electric current will an electric bulb draw? This is in page number 1 or 2. Okay, example 12.3. Page number 1 or 2. In that 12.3, how much current will an electric bulb draw from a 220 volt source? How much current will an electric bulb draw from a 220 volt source if the resistance of the bulb is 1200 ohms? So they are given potential difference. V is equal to 220 volts and resistance R is equal to 1200 ohms. So this bulb, they are telling the bulb is connected to a potential difference of 220 volts and the resistance of the filament of the bulb is 1200 volts. Now you have to calculate current drawn. That is I is equal to question mark. So now we know a relationship. According to Ohm's law, we know V is equal to I into R. Okay, so let me substitute all the values. So V is 220, that is equal to I is to be calculated and R is 1200. Okay, so now I is equal to cross multiplication 220 by 1200 is equal to 12 by 120, 22 by 120. I divide it by, I cancel zeros, I divide it by 2, 11, 60. 11 by 60. Let me find out the value of 11 by 60. 11 is smaller than 60, therefore I cannot divide it. So I put a point, take a 0. 60 2 is 150, therefore 60 ones are 60. 50 is the remainder. Again, I put a 0 here because 50 is smaller than 60 and I have already written point. So 60 into 8 is 480, 6 8s are 48, so 16 to 8 is 48, 480 and the remainder is 20, again I put as a point 0 here, 60, 200 divided by 60, I get 6, 3 is on, 63 is on 180 and this goes on 20, so this repeats, 0.1833, therefore current is equal to 0.1833 amperes. Okay, this is the expression. This is how you have to calculate. They had asked you to calculate the current drawn from the bulb when it is connected to a source of 220 volts, when the filament resistance of the filament was 1200 ohms. So you just wrote down whatever was given and then found out according to Ohm's law V is equal to IR. You substituted all the values here. And after substituting, you simplified and you got the value to be 0.1833 ampere. This is a solved problem and it is given to you in the page number 1 or 2. Page 1 or 2. Okay? Yeah. And let us see the B question of the same problem. Example 12.3, question B. How much current will an electric heater draw from volt source if the resistance of the heater is 100 ohm. Okay, so they are connecting a heater coil. Now in the previous problem they had connected a bulb. Now they are connecting a heater coil for the same potential difference. V is equal to 220 volts and the resistance of the heater coil is 100 ohms. Now you have to calculate the current drawn. Current should be drawn. Current should be calculated. You can use the same formula. V is equal to I into R. V is 220. I into 100. So I is equal to 220 by 100. That is 2.2 ampere. Okay. So this is how you will be calculating this. So in the second question, that is part B, how much current will an electric heater coil draw? They are asking how much will an electric heater coil draw from a 220 volt supply if the resistance of the coil is 100 ohms. Okay, resistance of the coil is 100 ohms and the power supply is 220 volts. So the current drawn is you calculate using this particular formula. So current is equal to 2.2 ampere. So this is your problem. Now, I had always been telling you while doing the chapter, current drawn by an electric but current drawn by a electric heater is very high, right? See, the current drawn by electric bulb is just 0.18 ampere, but the current drawn by heater is 2.2 ampere. This is why you cannot connect these two in series. Understood? This is what I was explaining you while talking about the disadvantages of series combination. Okay, is it clear? Yeah. Now let me move on to the next question. Yeah. This is 12.4, same page number 1 or 2. The question is example, I am talking about the example 12.4. Now, that telling the potential difference between terminals of an electric heater is 60 volt. When it draws a current of 4 ampere from the source, what current will the heater draw if the potential difference is increased to 120 ohms? Okay, what they are telling is they are connected an electric heater. Okay, I will draw a box here. This is the heater. Now this is connected to a battery whose supply is 60 volt. Potential difference is 60 volt. Then the current drawn from it is 4 ampere. Okay. Now what are they going to do in the second case? They are going to connect this heater to another battery whose potential difference is 120 volts and you have to find out the current. Okay, so they are telling you two cases. One case is heater connected to a 60 volt supply when the current is flowing is 4 ampere. If the current heater is connected to 60 volt supply, the current flowing is 4 ampere. Now, if the heater is connected to 120 volts, what is the current flowing? This is what you have to calculate. So first now let me write down the given data. So given potential difference, I write it as PD, potential difference V1 is equal to 60 volts. Then current I1 is equal to 4 ampere. Now according to Ohm's law, V1 is equal to I1 into R. I am writing just R because the resistance of, I'll come to it later, V1 is equal to I1 into R1. Now, V1 is 60 volts which is equal to 4 into R1. Okay, so this is one expression. Okay, now what I will do, or wait, let this be in this V1 is equal to I1 into R1. Now, let this be equation number 1. Now, potential difference V2 is equal to 120 volts. Now I have to calculate current I2. This is the question mark. Now what I do, V2 is equal to I2 into R2. This is equation number 2. Okay. So now, what? See, the same heater, the heater was same, they changed the potential difference, and so the current changed. But the heater is same, so therefore the resistance of the heater will always be same. The resistance of the heater will always be same in both the cases. So R1 is equal to R2. So I just write it as R, where R is the resistance. Now what I will do is, I will just divide equation 1 by equation 2. I am dividing 1 by 2. Equation 1 divided by equation 2. Okay, what is it going to give? V1 by V2 is equal to I1 by I2. Okay, this R and R will get cancelled. So V1 by V2 is equal to I1 by I2. Now substitute all the values V1, V2, I1 and I2. Substitute all V1, V2, I1 and I2. V1 is equal to 60. V2 is equal to 120. I1 is 4 ampere. So 4 divided by I2. Okay, now I have to solve this. First I will solve this. 61s are 62s are. So what I get? 1 by 2 is equal to 4 by I2. Okay, now I will just cross multiply. I will just cross multiply. So I2 is equal to 4 into 2, that is 8 ampere. So this is how I will have to solve this problem. Okay. I hope you have understood this problem. If you want, I will explain it clearly once again. I will use different colored chalks. See, in the first case, the heater was connected to a 60 volt supply. 60 volt supply. The current flowing was 4 ampere. Okay. Now what happened? They connected the same heater to another supply that is going to give you 120 volts, and they calculated to find the current. Okay. In both the cases, R is same. Resistance is same in both the cases because the same electrical supply is going to be, so the same electric heater is going to be connected to both the supplies. So what happened? So firstly, potential difference. Potential difference V1 is equal to 60 volts and current I1 is equal to 4 ampere. Therefore, according to Ohm's law, V1 is equal to I1 into R1, but R is same, R is equal, therefore R will be constant. Okay, so let this be equation number 1. Okay, now in the second case, what happened? In the second case, PD is equal to PD, potential difference, V2 was equal to 120 volts. Then current you had to calculate. Okay. In the next case, you had to calculate current, but the potential difference was same. And potential difference was double, that is 120 volt. But now current is R is same. Therefore, what will happen? V2, according to Ohm's law, V2 is equal to I2 into R. Understood? So now what am I going to do? Let this be equation number 2. So now what am I going to do? I will divide equation 1 by equation 2. Equation 1 divided by equation 2. Equation 1 divided by equation 2. So what do I get? Equation 1 is V1 is equal to I1 into R whole divided by equation 2. What is equation 2? V2 is equal to I2 into R. So V2 is equal